Okay, answer for the first problem. What's the velocity of a 36-inch diameter pipe sloped at 0.03%? So we're looking for velocity. We have two equations we're going to be working with. Q is equal to AV, and V is equal to 1.486 R to the 2/3 S to the 1/2 over N. This is nothing more than an algebra problem. Look at what variables you have, look at which ones you don't need or are looking for, and that'll help you determine which of the equations you work with. So in this case, velocity, we're going to use Manning equation. V will be equal to 1.486 times 3 over 4 to the 2/3 times 0.03 divided by 100, 0.0003 to the 1/2. Notice that was in percent. You got to make it feet per feet. Divided by 0.013. So my velocity will be equal to, let's see, 5 raised to the 2/3 times square root 0.0003 times 1.486 divide 0.013. I get a velocity of 1.63. So let's see what that does. 36 inches, 0.003. So here's 36, 0.0003. Yeah, we're less than 2. Okay. Is this a pipe that we could use on a system? No, because it's less than a velocity of 2, but that doesn't mean the calculations are any less correct. So we can get numbers. It just proves that water is moving too slow. How would you correct that? Increase the slope. If you increase the slope, the water moves faster. Now on to problem 2. Find the minimum diameter pipe to allow 45 CFS, that's Q, to flow with a slope of 0.002. So let's see, this would be Q is equal to area times velocity. 45 CFS is equal to the area times the velocity. Well, we don't have area, we don't have velocity. Let's look at our velocity equation. Velocity is equal to 1.486 R to the 2/3 S to the 1/2 over N. We have the slope, but again, we don't have the hydraulic radius there. So we can solve for that, or we can use the nomograph to find the diameter. And that's really the best use of that nomograph to help narrow down your selection. Trying to narrow down slope or velocity with nomographs is not really a recommended practice because there's too many options to choose from, and it's not, you're looking at very, very small differences in the numbers. You're not going to get as accurate of a number that you can just pick off the nomograph and throw that into the calculation. And I'll explain why in a second. So let's go 45 CFS and 0.002, so right through there. Okay, so looking at this, it looks like I'm right around 42 to 48 on my diameter. What's my velocity? Okay, my velocity looks to be, I'm saying it looks, about 4.7. That's not accurate enough to start sizing up the system based on that. So if we go to a 42 inch, I'm not sure if it's gonna be 42 or 48. So I'm gonna have to check both of them. I'm gonna try the 42 inch first. So if I do Q equals AV, and we say that, I'm sorry, we're not gonna use that. We'll use the Manning equation first, and I'll explain why. We don't have enough variables for Q equals AV at this point. We have an area, we'd be solving for the velocity. We want a velocity based on the pitch of the pipe. So velocity would be equal to 1.486 times 42 over 12 is 3.5 over 4 to the 2/3 times 0.002 to the 1/2 over 0.013. That would give me a velocity of, divided by 4 raised to the 2/3 times square root 0.002 times 1.486, divide 0.013. Velocity is 4.68. And again, we said 4.7. So if I now check that with Q is equal to AV, that would be equal to 3.5 squared pi over 4, that's the area of the pipe, times this velocity, 4.68 feet per second. Q would be equal to times 3.5 times 3.5 times pi, divide by 4, 44.99 CFS. Does this work? No, it doesn't. We need to hold 45. We get 44.99. Well, isn't that close enough? Nope. Okay, it's like getting a 64.99. It's not passing. It's not a 65. Now, for most of you, I'd probably round that up, but we'll see how it goes this semester. All right. But seriously, it's got to be 45. Don't try doing the rounding bit on this one. So we now go to the 48, and that I'm confident will work. The velocity will be based on 1.486 times 4 over 4 to the 2/3. That goes to 1. 0.002 to the 1/2 over 0.013. So square root of 0.002 times 1.486 divide 0.013. Velocity is 5.11. Q equals AV. So Q will be equal to 4 squared pi over 4 times 5.11 feet per second. 4 pi, 64.21 CFS. That's good. Okay, that works for us. So the minimum diameter that works on this, 48 inch. Let's just take this one step further. I need to handle 45 CFS. What other diameters work? 48 works, 54 works, 60 works, 66, we're less than 2 feet per second. So 60, 54, and 48, those work. Anything in that range would be acceptable. And you can use that nomograph to get you that range of numbers. That's what's so powerful with this. So please use that to your advantage. Problem number 3. Problem number 3 says find the diameter. Okay, diameter is what the nomographs are made for. So I'll jump right into that. 38.5 and a flow rate of 6. Okay, that looks pretty close. Let's see. So we want to find the actual size. So it's going to be somewhere between 33 and 36 inches based on the nomograph. So we're going to check into that. All right. So here is Q. Here is V. Q equals AV. We're looking for area. So area will be equal to Q over V. My area will be equal to 38.5 CFS over 6 feet per second. 38.5 divided by 6, 6.42 square feet. Now I want that to be turned into a diameter. So pi d squared over 4, that's area. That's equal to 6.42. So now to get that value for diameter, gotta go back to a little bit of math here. Multiply both sides by 4. That cancels. Divide both sides by pi. So d squared is equal to 6.42 times 4 divided by pi, 8.174. And if I square root both sides, d will be equal to 2.86. Now I said it was going to be between 33 to 36. And I'm getting 2.86. So why doesn't that number fit in between there? It does, because that's inches and that's feet. Don't forget your units. So if we want to see if it does fit, diameter would be 2.86 feet times 12 inches per foot times 12 is 34.3 inches. That's that actual number. Okay, looking good. Let's take a look at this last one then, problem 4. How much water will a 72-inch diameter pipe convey when sloped at 0.0006 feet per foot? So this slope is used with the Manning equation to find the velocity. So velocity will be 1.486 times 72 over 12 is 6 over 4 to the 2/3 times 0.0006 to the 1/2 over 0.013. 6 divided by 4, raise that to the 2/3 times square root of 0.0006 times 1.486 divide 0.013. That gives me a velocity of 3.67 feet per second. To find out how much water that conveys, Q is equal to AV. So Q will be equal to the diameter on this. This is 72 divided by 12. 6 squared pi over 4 times 3.67. Times 3, messed that up, 6 times 6 times pi times 3.67 divided by 4, 103.77 CFS. I think that's right. I wish I had a way to figure that out. I do. So 006 and 72. 006 is up here. 72 is there. Yep, I'm just above 100. So that's that. So it looks like I'm in the ballpark. It looks like my number is going to be accurate. All right, so those are some extra problems. Hopefully you get a chance to go through those. Other than that, hopefully you have a great weekend. Please study.